Okay, hello everyone. We have Webab with us. Webab is a research and development professional, and he's with us to talk about science as such. So, Webab, my first question to you is what is science, and how can someone believe in something that changes every week? We hear things changing every week. How can we believe in something like that?
What do you think science is?
See, basically, I understand as a common person, I understand science about the technology, the things that we, develop, we innovate, like satellite, mobile phones, bridges, building, and these kind of things, like which are of public use. So that is what I understand from science.
Well, you're right. You're right in a way. Let me give you an example. Uh, some people like cooking, right?
Right.
And if science is cooking, then what you are describing as science are dishes that come out of that kitchen.
Okay.
And something that happens inside the kitchen is what people love. That is what science is. So what I am trying to do today is to take you inside the kitchen and show you what really happens inside the kitchen. Because everything is a good kitchen and a good process inside a kitchen would lead to good dishes.
Right.
So all of those good things that you're talking about and the bad things you're talking about are a result of a process that happens inside the kitchen. So let's have a peep inside the kitchen today. Having said that, coming to your second question, why does it change every week and how can I trust something that changes every week? Well, it's fashionable nowadays not to trust science and scientists. But you see, the point is that let us take an historical view of it. Science was originally called natural philosophy. Now it is made up of three words. Natural is something that pertains to nature. Philosophy is philo and Sophie. Philo is love and Sophie is the goddess of knowledge, Sophia. So anything love for knowledge and knowledge about nature is what science is. And I love that term much more than I love the term science. Now the enormous success of science, the technologies that you talked about right now, your mobile phones, your rockets, your satellites, your buildings, that enormous success of scientific enterprise that has led to a lot of other fields to co-opt that term, to start using that term. And strictly speaking, those are not there. Those are not sciences in the sense that natural philosophy is a science, in the sense that physics and chemistry is a science, or biology is a science. For example, political science. Political science has nothing to do with nature. It's about human beings. We talk about science of rearing children nowadays. It's an art, and that is what changes every week. You don't have the real sciences change every week. The fundamentals of science remain unchanged for very long time. Still, so that is one aspect of it, right? The other aspect of it is that there's a difference between science and science reporting. So when it's an era of fast reporting, fast news. So what actually happens is that these reporters, they hang out with scientists in restaurants and cafeteria, around their labs, and they catch snatches of what they are conversing about, what they are talking about. And once they do that, they publish it into a new story, which is something that is not ripe for publication. You must have heard of that gravitational wave detection that happened last year,
Yes.
exactly 1 year back. Now that was announced, I think in September. But you know when it was really observed? It was observed about 6 months before the announcement. And what did the scientists do in 6 months? They validated, they really hammered it in, they really rechecked and rechecked and tried to replicate their data using different analysis methods, and only then they came up with that announcement. Now what science reporters do is they prematurely announce things, and then when those things, obviously by virtue of not being mature enough, when they go back, so you get an impression that it changes every week. So that is not really true. So in scientific parlance, they announce the hypotheses, they don't announce the theories, and hypotheses are designed so that they can change. It's not the theories that change. And we'll talk about those terms as well. Now the third thing is that uh, what happens? Like for example, if you're doing an experiment, for example, if you like cooking, don't you?
Yeah.
So if you're doing an experiment in the kitchen, do you like your experiment to succeed or to fail?
To succeed.
To succeed. Now there is a slight difference in the mindset of scientists and common people. Scientists like their experiments to fail because any failure in experiment will give rise to new science, to new insights. When you have an experiment confirm your hypotheses, it's the end of your learning. So your hypothesis then graduates, and then that's the end of it. But when your experiments fail, they give you a new data point to think about, a new theory to think about, a new reason to think about. Sorry, a new experiment to think about. So that is. So scientists don't like successes as much as they like failures. So if you must have heard of Higgs boson,
Yeah.
right? And Peter Higgs got a Nobel Prize for it recently. Now LHC came up with the discovery of Higgs boson, and in popular media that was a huge success. But in scientific community, what happened was that the discovery of Higgs boson was not such a phenomenal success, but because it confirmed the standard model of physics, the standard model of quantum mechanics, that is about 40 years back, 40 years old. Now what really happens here is that there are some gaps in understanding based on the standard model, and we were hoping for something new to turn up. But what turned up was exactly what could be predicted using the standard model. So there was no new physics that came out of it. So that is something that does not make it as exciting, right? So that is the third aspect of it. Why you perceive that sciences, that is the hard sciences, the natural philosophy part of it, that changes every day. So that is the third part of it. We were talking about science and how popular media, how it presents science, and how our school education presents science is not really science. It's the dish, it's the delicacy that comes out of the kitchen. And science is what actually happens inside the kitchen.
Right.
Now, you see, you have scientific terminology that people are not aware of, basic, fundamental, and I'm talking about world leaders and top level people who don't know what a theory is, what a hypothesis is, what all these things are, and that gives you a very bad taste in your mouth sometimes, because science is critical to our well-being today, and if you don't understand it as a temperament and as a mindset, you tend to misunderstand the point of view of science, and you come across as an intolerant or an unsocial or an antisocial person. Now the thing is that scientists by their very nature, and the people who gravitate to science are people who are in love with truth, and they are generally by their very nature are not very social people, and that is a stereotype, but that is largely true as well. But that should not rather be due to the fact that their thinking is tempered by levels of rationality that ordinary people cannot really appreciate.
So, like you talked about the various terms, hypothesis, theory, rules of science. So, can you throw some light on it? Like, what are these terms mean actually, and not in a general way?
Yeah, I would like to do that. But the thing is that, the word theory, for example. Theory means something in common parlance. In common English, theory is something that you say, I theorize that this would be happening due to this reason. It's just a guess. Like in science, there's something in science which is like co-opting the terms. So you co-opt the terms and give them a slightly different meaning. For example, in physics, work means force times displacement. If there is no displacement, there is no work. So if you are sitting on your desk, and like for example, you are shooting this video. So this is not work for physics. But we'll get tired. We'll obviously need food to replenish ourselves, and that is work in common terms. But that's not work for physics. Similarly, the word theory, the word hypothesis, the word law, the word fact, they have slightly different meanings in science. So what actually happens is you start with a fact. You see something, that's a fact. So for example, I'll try and give you an example. So in 1970s, very recently, these two guys, Panzias and Wilson, they were doing their PhD and they were trying to do some radar-based interferometry or radar-based studies, and they could observe a steady background noise, a very steady noise that they could observe and they could not get rid of it. So that is a fact, and that is a fact that they see in the data. So fact is anything that is visible in your data, that is visible to everyone else. There is no quarreling about it. There is no repudiation. There is no nothing about it. Now you come up with a hypothesis. Hypothesis is what we call a theory in common English. Hypothesis is a guess, a best guess as to why this must be happening. So first guess was it must be pigeon poop, pigeon droppings that have fallen onto the radar dish. They are causing it. So they developed a lot of pigeon trappers, a lot of kind of nets so that birds cannot sit on the dish and do it. And that was a hypothesis. First hypothesis, it's due to pigeon droppings. Now, and then they did an experiment. Now the key thing to note is any hypothesis has to be falsifiable, and that's a new term, I think. Falsifiability is that you have to define upfront what you can do so that this hypothesis can be proved wrong. You don't want to prove the hypothesis right. You need to know upfront what makes it wrong. So what made that bird poop hypothesis wrong was that if you remove the bird poop, if you remove the birds, that background noise would go away, background radio noise would go away. Now what they did an experiment. They cleaned up the dish, nothing happened. There was no impact. Then they erected a net so that birds cannot come and sit on it. Even that didn't make any difference. So that was an experiment to prove or disprove a hypothesis. And eventually this experiment disproved that hypothesis. So you go back to the drawing board. Now when you listen to this term going back to the drawing board, which in popular media it is like there was a phenomenal new experiment, there is a great new experiment and scientists go back to the drawing board. My friend, scientists are always on the drawing board. They never put their feet up and say, I'm done, my life's work is done. Oh, okay, that doesn't happen. Scientists are always on the drawing board. So they went back to the drawing board. They came up with yet another theory that this must be some external interference from a military aircraft or something. And what do? They they take their setup somewhere else, and they see that it's the same there as well. So that hypothesis is also proved wrong. Now the third hypothesis was that it is coming from space, and they kind of changed the orientation, and this background noise was amazingly uniform, and the only thing that is that uniform is space. There is nothing else on earth that is that uniform. So that was a hypothesis that was born out of experiment, and then they discovered that what they were hearing was the remnant of the Big Bang, the cosmic microwave background. They got a Nobel Prize for it later on, but that was the last vestige of a Big Bang. Big Bang is when the space and time as we know it came into existence. So then after all that happened, it became a theory. Now the theory is a hypothesis that has been proved right by experiment. Theory is not just a hand-wavy explanation of something. So that was a theory. Now theory was something that was born out of experiments. It was a hypothesis proved right after experiment. It's not that hand-wavy thing that my best guess is that this is happening due to this reason. So the journey of an idea is you start with a hypothesis. And the hypothesis is there to explain a fact. So you come up with a fact, you have an hypothesis which is falsifiable, which can be proved wrong, and then you do experiments to prove it wrong. The key thing is, as we said, you don't feel happy when the experiment proves you right, you feel happy when the experiment proves you wrong. So you do an experiment which proves the hypothesis right, and if it doesn't, then it becomes a tentative theory. And then once it becomes a tentative theory, then you replicate. So there is something called replication. So other people will replicate the same experiment. If they observe the same thing, then your experimental fact is solid. And then a theory always has, in science, it has predictive power. So a theory's test is to apply it to a scenario where it has not been applied, and then see whether it gives the results that you observe. So you test your theories, and then repeated tests cement that theory. So then it becomes a real theory which will not change very easily. And then you need extraordinary. Now see, when you establish a theory now, after this process, you have a body of evidence behind it. And no small experiment is going to overthrow it. So when you say that extraordinary events require extraordinary evidence, that is what it is. So in order to move an entrenched theory, you need a substantial body of experiments which need to be replicated by many people across the community, and then the theory is overthrown. So by its very nature, the theory passes through so many levels where it can be rejected. It is not very easy for it to change every week, as science reporting would lead you to believe. But what actually happens is that they report on hypotheses rather than theories. So, well, that's the name of the game. So, if you really understand the methods of science, you can understand that this is, and the scientists are incredibly their humility is incredible. So, if you remember, very recently there were, during this very experiment, the LHC, the Atlas team reported that they found neutrinos that were traveling faster than light. Now the press release, if you read it, it was not as if we are the achievers of the world because we have overthrown Einstein and we now are at the top of the world or something. It was not like that. It was very subdued. And the press release was, we found neutrinos that we found were traveling faster than light, and we would like the scientific community to figure out what went wrong with our experiment. So they themselves were second guessing themselves. That second guessing, that humility, even when you are at the apex of accomplishment, is something that is very unique to science. Now, the mindset of a scientist is very unlike the mindset of a common man. So we need to understand what the mindset of a scientist is.
Right.
So a scientist is driven by skepticism, for example. First thing is, he needs to be a skeptic. He needs to understand, and he does not need to believe. And that belief in anything without evidence, or belief in anything, belief in itself is something that you believe without evidence. So belief in anything is counterintuitive and counterproductive in science. So you don't believe, you question everything. And a scientist has to be a contrarian and a non-conformist. He does not need to confirm. So people believe that Earth was flat. The majority of the world believed that it was flat. Never made it true, right? The Earth is round. Never made it correct. So you need courage to go against popular opinion. And the purity of thought that a scientist has, the purity of understanding that he has, and the sheer love for knowledge is what gives scientists the bliss that he receives in science. And that joy, that pleasure of discovery, and the pleasure of being in sync with the symphony of the universe is what drives people towards science. And that is what should. It's not about the results of science, it is about the pleasure that you derive. And people live and die without having that moment once, and you'd be lucky if you can have that bliss even once in your lifetime, in your career, when you can really feel that you are in touch and you are really feeling the hand of the God in the creation.